Hello. So I will be going over the mechanics exam that some of us have had. We will be going over some of the questions. So we'll go through them one by one just to see how to answer them because it was quite a tricky exam. So the first question, 1A, gives you a bunch of information. A train travels along a straight horizontal track between two stations, A and B. The train starts from rest at station A and accelerates uniformly, so at a constant acceleration, for t seconds until it reaches a speed of 20 meters per second. The train then travels at a constant speed of 20 meters per second for 3 minutes before deaccelerating uniformly until it comes to rest at station B. The magnitude of the acceleration of the train is twice the magnitude of the deacceleration. And then it asks you to sketch below a speed-time graph showing the motion of the train as it moves from station A to station B. So they tell us that the acceleration is 2 times bigger than the deacceleration. So when drawing your graph, make sure that your line for acceleration should be about 2 times steeper than that for the deacceleration. It doesn't have to be too exact, that doesn't matter too much, but you have to show that the acceleration is steeper than the deacceleration because it's bigger. And because it takes twice as long to deaccelerate, then your time should also be twice as big. So I'm going to write, so it says that the train accelerates uniformly for how long? T seconds. So this part of the journey is T seconds. And then it travels at a constant speed of 20 meters per second for 3 minutes. So that would mean 20 meters per second here. And 3 minutes, of course, we want the time in seconds. So 3 times 60 is 180 seconds. So this time of the journey is 180 seconds. And then the last part, which has to be a longer deacceleration. And because it's deaccelerating twice as slower, that means it's going to take 2 times longer, so 2t. And that should be your graph. Make sure to label the 20 and the different times. You could also write this to be t seconds, this to be 180 plus t, and the last part to be 180 plus 3t. Time has passed. And that should give you your 3 marks there. And then it tells you station A and B are 4.8 kilometers apart. Find the value of t. Part B tells us that the stations are 4.8 kilometers apart, but we want to work in meters. So 4.8 kilometers is the same as 4,800 meters. And we know that the distance traveled on a speed-time graph is equal to the area underneath the line, the curves that we move. So this is a trapezium shape, and the area of a trapezium is A plus B times the height divided by 2. So the top length plus the bottom length times the height, all divided by 2. So, and that would be the area, which is the distance traveled, 4,800 is equal to, the top side is 180, plus the bottom length is in total is 180 plus 3t. And then the height is 20 divided by 2. So 20 divided by 2 is 10. So I can divide all of this immediately by 10 by moving it to the other side. So we would have 4,800 divided by 10 equals 180 plus 180 is 360 plus 3t. So that means 4,800 divided by 10 is 480. So 3t plus 360 is 480. 360, move that to the other side, do 480 minus 360, 120. T equals 120 divided by 3 is 40. So T is 40 seconds, and that's part B. Of course, if you have any questions, feel free to message me, or I mean, if this goes on YouTube, then there's also the comment section, so you can use that, of course. And then I can answer a question and everyone can see the answer, so maybe it's useful for everyone else too. Some important information to keep in mind is that T is 40 seconds. And in part C, find the acceleration of the train during the first T seconds of its motion. This is a SUVAT question. We want to find the acceleration because we know the time is t, which we calculate to be 40 seconds. The initial velocity, because it starts from rest, is going to be 0. And the final velocity is 20. And the time, the distance traveled during that first piece of the journey, we don't care about. So here we have u, v, a, and t. So we can use the equation v equals u plus a t, or you can rearrange it to make a the subject, a equals v minus u divided by t. So you get a equals 20 minus 0 divided by 40. 20 minus 0 is just 20, and then 20 divided by 40 is a half, or 0.5 meters per second to the minus 2. And that's your answer for part C. Alright, the next question on the exam, which was question 2, talks about two students who see a book fall from a bookshelf, and this is our bookshelf, and they have different models to help figure out how does the book fall. So depending on the model you use, it'll be more accurate or less accurate. So they want you to calculate two different models for two different parts. Part A for one of the students and part B for the other student. The students knows that the book has a mass of 0.2 kilograms and it falls 1.5 meters, starting from rest. Student A suggests that the book is modeled as a particle falling freely under gravity. So because the book is modeled as a particle, we can ignore any sort of air resistance or anything like that. So then it asks, use student A's model to find the time taken for the book to reach the floor. So part A is going to be a SUVAT question. Student A's model is much easier to work with because it doesn't consider air resistance or anything like that. The distance the book falls is 1.5 meters. Starting from rest, the book will accelerate because it's falling freely. Under gravity, the acceleration will be g, or 9.8 in mechanics, but I'm going to leave it as g for now. You can put 9.8, it doesn't matter. And they ask you to find the time that it takes for the book to fall. So that's this one. So here we have S, U, A, and T. So I'd say we use S equals UT plus a half AT squared. So S is 1.5 equals UT. U is 0, T we don't know, but because U is 0, it's just going to be 0 times T, so I'm not going to write it, there's no point. Plus a half A is G, a half GT squared. So I'm going to I'm going to get T by itself by multiplying this side by 2 instead of dividing by 2, and then dividing by G. So you move around, you solve for T. T squared equals 2 times 1.5 is 3 divided by G, and that means T equals the square root of 3 over G, which is 9.8. And then if you put that in your calculator, you get approximately 0.553 seconds. And that is your answer. So if you look at the mark scheme, which the teacher sent on the OneNote, you will notice that the questions in the mark scheme are not in the order of the paper. So make sure to take note of that and don't confuse yourself. Part B is when we use Student B's model. Student B suggests an improved model where the book is modeled as a particle experiencing a constant resistance to motion of magnitude r. So now it's kind of considering some sort of force that's acting against it falling, so like air resistance or something like that. And its magnitude, this amount, is r newtons. Given that the time taken for the book to reach the floor is 0.6 seconds, use Student B's model to find the value of r. So because we're working with forces, we know that we probably have to use the formula F equals ma. Plus we're also given the mass, so that makes more sense. Now we don't know what the acceleration is, because this time the acceleration is not the acceleration due to gravity, because it's got this other force acting that's slowing it down slightly. So the acceleration will be a little bit less than 9.8. So we can calculate it again using SUVAT. S-U-V-A-T. The distance is still 1.5 meters and it starts from rest. We want to find the acceleration, and it tells us this time is 0.6. And we can see that that means that it's been falling for slightly longer because of this resistive force than Student A's model. Something to notice. So here we have S, U, A, and T. So I'd say use same formula as before this time. S equals UT plus a half AT squared. Again, use 0, so I'm not going to write that part. 1.5 equals a half of 0.6 squared times whatever the acceleration is. So the acceleration would be 0.6 squared divided by 2. 0.6 squared divided by 2 is 0.18. So 1.5 is equal to 0.18 A. A equals 1.5 divided by 0.18. And you get an answer of about 8.33 meters per second to the minus 2, to the 3 significant figures. So that's our acceleration. And we know that this makes sense because it's a little bit less than gravity, and it's less than 9.8 because it's got that resistive force. So now if we use F equals ma, the force is going to be its weight acting down minus this resistive force countering it. So its weight is going to be its mass, 0.2, times the gravity, that's how you calculate weight, minus this resistive force is equal to the mass, 0.2, times our acceleration of 8.33. 8.33 times 0.2 is 1.67. Use more accurate results from your calculator during your working. Only round at the very end. That's a better idea. So you rearrange and you will get r equals 0.2 g minus 1.67. And then g is 9.8, so 0.2 times 9.8 minus 1.67, or whatever your calculator tells you. And you should get an answer of about 0.29 newtons. Don't forget your units. So that is how we would find the Student B's resistive force that makes the model more accurate. And that's question 2. The next question tells us about, it talks about a lift. So I've copied down the diagram from the book, similar, from the exam paper. A simple lift operated by means of a vertical cable which is attached to the top of the lift. The lift has mass m. The box Q is placed on the floor of the lift. The box P is placed vertically on top of box Q, as shown in figure. So we have a lift, which has a mass of m kilograms, and then it's being held up by a rope that's pulling it upwards, and it has a box Q and a box P on top of box Q. The cable is modeled to be light and inextensible, and the air resistance is modeled as being negligible. So we can ignore those external forces. The tension in the cable is 42 mg over 5, and the lift and its constants accelerate upwards by 2g over 5. Using this model, find in terms of m the combined masses of box P and Q. So because the box P and Q are placed together, we can think of them as one object, and we're going to find their combined mass because of as if they are one object. We know F equals ma. The force that's lifting all of this up is the tension that's pulling upwards. So this tension has a force of 42 mg over 5. 42 mg over 5. But it has this opposite force, which is the weight of everything. So the weight of the lift minus m, and then the weight of the two boxes, which we don't know. So I'm going to call it, the weight, because it's the weight, it's going to be mg, or m is just the mass, minus whatever the masses of the two boxes combined, their weight. I'm going to say their mass is x, so xg, and that it gives you all of their combined masses of m times the acceleration. So the combined masses would be the mass of the lift m plus the mass of the objects, which we call x. So P and Q have a mass of x kilograms. So the acceleration would be m plus x times what we know is 2g over 5. Okay? So I'm going to start by getting rid of the fractions and multiply everything by 5, just so we don't have to deal with fractions. 42 mg minus 5 mg minus 5xg equals 2g m plus x. I'm actually going to expand these brackets. So 2g times m is 2 mg, and 2g times x is 2xg. Now we can rearrange everything. I'm going to move all the x's to one side and everything else to the other side. So 42 mg, and because we have 42 mg minus 5 mg, that is the same as 37. And then we do minus 2 mg because we move it over, equals, we move this one to that side, 2xg plus 5xg. Now, because everything has a g, I can just cancel the g's out. So the g's can go, and then I'm left with only values of m and x. So 37m minus 2m is 35m equals 2x plus 5x is 7x. And then that means x is 35m divided by 7 is 5m. So that means that their combined masses would be 5m. Part B says, during the motion of the lift, the force exerted on box P by box Q is 14 mg over 5. Using the model, find in terms of m the mass of box P. So now, if we look specifically on box P, we know that everything is accelerating upwards at the same speed, 2g over 5. So if we look at box P, if it has this upward force, it has to have a downward force, which will equal to its mass times the acceleration that it's at. So we can write this out as F equals ma. F equals ma. where we have the upwards force is the force that Q is exerting on P, which it tells us is 14 mg over 5 minus the downwards force, which will be the weight of box P, which would be its mass. I'm going to call that P. The mass of P is, well, P. And then times the G, because it's the weight, is equal to it's the mass of the box, which we said was P, times the acceleration, 2g over 5. So just like before, everything has I'm going to multiply by 5 to get rid of the fractions. 14 mg minus 5 pg equals 2gp. Alright? And because everything has a g, I can just divide by g and get rid of all the g's, so cancel everything out. Cancel out those g's. And then we're left with 14m minus 5p equals 2p. So move that over to the other side. 14m equals 2p plus 5p. 2p plus 5p is 7p equals 14m. And then if we want just p is equal to 14m divided by 7, which is 2m. So now we know that the mass of P is going to be 2m. And that's how you do part B for this question. Okay, the last question from the paper. Almost there. So there's a huge block of text which tells you that we have two particles, P and Q, that have a masses of m kilograms and 4m kilograms. The particles are attached to the end of a light inextensible string, so the string. Particle P is held at rest on a rough horizontal plane, so it's going to experience friction if it's rough. And then the string lies along the table and passes over a small, smooth, light pulley, so the pulley, which is fixed at the edge of the table. Particle Q hangs at rest vertically below the pulley at a height h above the horizontal plane. So Q is hanging from a height h above the plane. The coefficient of friction between P and the table is 0.5. The particle P is released from rest and the string taut slides along the table. So we release P and then this starts falling and that's dragged along the table. So the question here that probably got some people stuck was, what is the coefficient of friction? Now, the coefficient of friction is quite simple to understand. It's just a number. So if you have the coefficient of friction, which we can represent by this symbol, times the weight of an object gives you the resistance. So if you take the weight of P and you multiply it by the coefficient of friction, that gives you this resistance force that it has because it's on a rough plane, this rough table. Find in terms of mg the tension in the string while both particles are moving. So that's part A. And to do part A, you need to know the resistance on P. So we can find the resistance by doing the coefficient of friction, which they told us was 0.5, times the weight of P, which is its mass, m, times g. So mg is equal to 0.5 mg. And that is the frictional force. That's how much it is, newtons. That's all. So then what we have to do is we need to find out, it wants us to find the tension in the string, so we can do that using F equals ma. F equals ma. So if I draw the tension here, there's tension on the string, and of course this is accelerating downwards, which means this will be accelerating that way, and the acceleration will be the same because it's like an inextensible string. So what we can do is we can look at the forces. So Q is falling down at what acceleration? It depends on the force. So the force that it's feeling downwards is its weight, which would be 4m times g, because that's the weight. minus the tension, because the tension is pulling it back up. So minus T is equal to its mass 4m times the acceleration A. And then the second equation we will have is for the particle P. P is being pulled along by the tension, so it has T minus the resistance that it's feeling from the rough surface that's pulling in the opposite direction, which we calculated to be 0.5 mg is equal to its mass m times the acceleration A. So now all this is simultaneous equations, so we want to find T. I'm going to make A the subject in each equation, so that would mean for this one, A equals 4mg minus T divided by 4m, and then over here, A equals T minus 0.5 mg over m. So now we have two equations that equal A, so we can just make them equal each other. 4mg minus T over 4m equals T minus 0.5 mg over m. So because on both sides we're dividing by m, I'm going to multiply by m, so that cancels out this m that we're dividing by. And then all I'm going to do is multiply this side by 4, so that we don't have the fraction anymore. So 4mg minus T equals 4T minus 2mg. And then we just make T the subject, so we move things around. 4mg plus 2mg equals 5T. 4mg plus 2mg is 6mg, and then equals 5T, so we just divide by 5, equals 5T. So the tension is 6 over 5 mg. And you might be wondering, should you take G and make it into 9.81? 9.8. Mechanics is 9.8. So you can multiply it by 9.8, so you only have the letter M there. But if you look later in the questions, like in part B, it shows G in one of the answers. So because in the question they're using G as part of their solutions, I'm going to leave it as G, because maybe that might make my calculations easier later. So that's part A, where you find the tension, two simultaneous equations. Okay, so it says particle P does not reach the pulley before Q hits the plane. So that's important, because that means that Q can fall all the way down without the particle P reaching the pulley and stopping everything. And then it says show that the speed of Q immediately before it hits the pulley, the plane, is square root of 1.4 GH. Now because it's working with decimals, I'm going to quickly convert this into a decimal. 6 divided by 5 is just 1.2. And it says show that the speed of Q immediately before it hits the plane. So that's the final velocity, which means we're doing suvat. But to do suvat, we need the acceleration. Lucky for us, we had those formulas last time which had acceleration in them. So this is one of the formulas we used before when we calculated T. Now that we know T, we can put it in and we can find A in terms of M. So 4mg minus T, T is 1.2 mg. So 4mg minus 1.2 mg divided by 4m. Everything has an m, so I can cancel those m's out. Equals 4g minus 1.2g is 2.8 g over 4, and 2.8 divided by 4 is 0.7 g. So that's our acceleration, so I'm going to make a note of that too. And then the last thing we have to do is suvat to find the final velocity. Well, to show that, because it tells us that the final velocity, what it is going to be. So because it's dropped at rest, we know the initial velocity is 0. The distance it falls is h. The final velocity is what we're trying to work out, and we just found out the acceleration is 0.7 g. The time we don't care about. So SUVA, that's the square, as our physics teacher likes to call it. V squared equals u squared plus 2as. So v squared equals 0 squared plus 2 times 0.7 g times h. So 0 squared is nothing, so I'm going to not write it anymore. There's no point. V squared equals 2 times 0.7 g is 1.4 g, 1.4 g times h, 1.4 gh. So then v equals the square root of 1.4 gh. And if you look, that is exactly what it told us to show that the final velocity is. So that's our calculation. The last question is worth 6 marks. When Q hits the plane, Q does not rebound, so that means it stays on the plane. It just falls down and it doesn't bounce. And P continues to slide along the table because P does not suddenly just stop. When Q stops, it can still slide a bit. But given that P comes to rest before it reaches the pulley, show that the total length of the string must be greater than 2.4 h. So because P travels a certain distance and then deaccelerates a certain distance, they tell us it doesn't reach the pulley, which means that the string here, whatever that distance is, it has to be greater than that, or else it would have reached the pulley at that point. So it kind of immediately give away, if you read the question properly, it tells you your final answer, the distance that P travels in total should be 2.4 h. So now we can try and calculate that. So there are 2 stages to P's journey. The first stage is when it's accelerating because Q is falling, and then the second part is when Q hits the bottom and it's deaccelerating. Now, because P is accelerating at the same rate, that means when Q is falling, it travels the same distance as Q. So in the first part of the journey, when it's accelerating, would be h. That's how far it travels. And then the second part is when it deaccelerates. Now, because it accelerated at the same rate, that point at the start would be the same as the final velocity for Q, because that happens right after and they were accelerating at the same rate. So we can use SUVAT to work out how far P travels in that second half. SUVAT. We want to work out the distance. We know the initial velocity is now what was the final velocity before, 1.4 gh. And then the final velocity is when it comes to rest, so 0. The time we don't care about. We need the deacceleration. How fast does it deaccelerate? And we can calculate that as before, F equals ma. Now that there's no tension, nothing pulling P forward, the only force acting on it will be the back force of the resistance because of the rough surface. So that's going to be the, before we had T minus, that resistive force, now it's only T0, so it's just the minus 0.5 mg equals the mass m times the acceleration. So we have m on both sides, so we can cancel them out, and that means the deacceleration would be minus 0.5 g. And that's our deacceleration. So that's what we have to write here, minus 0.5 g. Okay, I'm seeing S, U, V, and A. That means, again, square, with the 2 squares in it. So V squared equals U squared plus 2AS. However, I'm going to rewrite this to make S the subject because that's what we're looking for. So if you rewrite it, you get V squared minus U squared divided by 2A. So S equals V squared, 0 squared, minus the initial velocity square root of 1.4 gh squared divided by 2 times minus 0.5 g. And then if you look at that, 0 squared we don't care about because it doesn't equal anything, minus a square root of 1.4 gh squared. Because there's a square root and a square, they cancel each other out, so it's just minus 1.4 gh divided by 2 times minus 0.5 g is just minus g. So the minuses we can remove because a minus divided by a minus is a positive, and the g's we can remove because they both have g. So 1.4 h. And that's the distance that P travels in the second half. So this part is 1.4 h. So the total distance that P travels has to be those two added together. So h plus 1.4 h equals 2.4 h, and that is what it says in the answer. It says here, show that the length of the string must be greater than 2.4 h. So if we want P not to hit the pulley, the string, the distance that it is from the pulley, has to be greater than 2.4 h. And that's the last part of the question. So those are all of the questions. If you have any questions, if you didn't understand anything, or there's some things you want to check, feel free to message me, or I guess a comment. It's up to you. And yeah, I hope this helped you guys with your mechanics revision. Good luck on your mock exams or final exams, or whenever you're watching this.